to go over a few topics in Matlab. So Matlab is essentially speaking a programming language, and so using it in our course together is indeed very useful. If we use a percent sign in our code, which I'll show in 1 second here on the left, but if we use a percent sign, this allows us to write a comment, which, as you will see when I use that here in Matlab, it will comment it out. So let me start a new script here to show this. So if I put the percentage sign, this is a comment. Notice how it's in green and it's commented out. And we could assign variables, right? So if I did something like A, not capitalizing it, is equal to, let's say, 5. Right, and I put that into Matlab. You would notice if I tried to run this and give it a name, and give it a proper name, there we go. If I tried to run this with A is equal to 5 in the code, what comes out from our command window here? A is equal to 5. In order to stop that from happening, we will need to include a semicolon in our code, which now when we run it, nothing displays. And we could do the same thing if we want another variable. Let's call it B, and we could set that equal to, let's do 6. So B is equal to 6. Alright. And we could use a whole bunch of operations. So such as C is equal to A plus B, D is equal to A times B, E is equal to A divided by B, and that does allow us to use decimals. I know some programming languages don't. We could do F is equal to A minus B. We could do G is equal to log of A. This is the natural logarithm. H, we could do log 10 of A. And this is a logarithm base 10. We could do I is equal to A to the B power for an exponent. We could do J is equal to mod A comma B. A comma B if this does not want to autocorrect me. There we go. What that does, that did autocorrect me. What that does is this gives the remainder. Gives the remainder when A is divided by B. We could also use, for that remainder, rem of A comma B. And that will give us the same thing if it does not want to autocorrect me. That will give the same exact thing as the remainder as well. So showing all of that in SAS, and Matlab, excuse me, I'm just going to copy all that over instead of retyping out each one. There we go. Now when I run this, it should give us all these values. Unless, of course, one of the A's decides not to go nicely, that being on line 14, this one. And that's because of the way that I have that on there. There we go. And so now when you actually type it in correctly, it gives us different values. So for this addition of the two variables, that's 11. Multiplication is 30. Division is 0.8333. Subtraction is -1. Doing the natural logarithm of 5, that's 1.6094. For the logarithm base 10 of 5, that is 0.6990. For 5 to the 6th power, that's 15,625. And then for when we do 5 divided by 6, we get a remainder of 5 both times. We could also use the who command, and that will just list all variables used in the program at the time. So if I include on here who, you will see at the end it gives all the variables, which you could also see in the workspace here in Matlab. Now, when it comes to these variables, we could also make an array. Alright, and for this array, and let me just give myself more room on here to type, we're going to call our array the variable x. We're going to start at the number 0, increase each value by 1 until we get to the number 10. So this starts at 0, increases each entry by 1 until it reaches 10. So if I do that, x is equal to 0, colon 1, colon 10. We could also apply an operation on that. So let's say y is equal, let's say we want to square each of these values. We're going to use x. We need to put a period though before squaring this, due to the fact that this is an array. So doing that will give us this. Y is equal to x period, and then that caret 2. So now running this will give us the square of each of those values of x. If we wanted to display those values of x, let me get rid of the semicolon. We can see all the values of x from 0 to 10, and all the squares 0 to 100. We could even plot a graph of this, which will be a parabola in this case, but we use plot x comma y. And we can see what happens with that. Plot x comma y. And then hit run. This will produce a graph here of the parabola from our values of 0 up to 10 from the x-axis, and then the y-axis are these other values 0 to 100. Let me know if you have any questions or concerns about these, a few of these MATLAB basics. Thank you.